Today we're going to start with angle addition proofs, which can be some of the most challenging proofs simply because it's the first time we've ever done it. So the first thing I would encourage you to do always is to label your diagram. So we have angle 1 is congruent to angle 3, so we mark those congruent, and angle 2 is congruent to angle 4, so we mark those congruent. And this we should offset just a little bit. The prove we never label in the diagram. We only want to label in the diagram what we know to be true, and the prove is what we're trying to get to. So let's begin first by talking about the format of the proof. We're going to go ahead and put our givens in here. And we know we're trying to prove angle ABC. Oops, I'm putting it all the way down at the bottom here. Is congruent to angle DEF. And one of the things you need to make sure that you understand is that in order to do substitution or angle addition or any of these other things, with one exception, we have to convert them all to equality. So the very first step will be to convert these to equality. And in the same token, we can convert at the end to equality as well. For example, the measure of angle ABC is equal to the measure of angle DEF, because if the two angles are congruent, then the two measures of those angles have to be equal. Okay? In the first part here, we're going to do something special with them when we convert them. And before we can talk about what that's going to be, we need to look at this proof. There are two main types of angle addition proofs. One's where we add two smaller angles to get a larger angle, or ones where we subtract to get to a smaller angle. So 1 and 3 are single angles, so I'm going to call those parts. And 2 and 4 are also single angles, so I'm going to call that a part. But ABC is made up of more than one angle, and so is DEF, so I'm going to call those guys wholes. And this should start ringing a bell here. Part plus part equals whole is angle addition. So what I want you to think about, if we have these two parts and we're trying to get to the whole, are we going to add the two parts or subtract them to get to the whole? And what the answer is, we would need to add the two parts to get to the whole. So this is an addition proof. Okay? So if we want to add them, since it's an addition proof, we want to go ahead and stack the givens, and you'll see why in a moment. So instead of writing them horizontally like this, when we convert them to equality, we want to stack them. So the measure of angle 1 equals the measure of angle 3, and then stack this guy underneath. The measure of angle 2 equals the measure of angle 4. So we did the same thing we did down here, but down here I just changed the format a little bit so we can do the next step. So when you convert from congruent to equality, we will call that definition of congruent angles. And when we convert down at the bottom, that's going to be the same reason. But one thing you should understand is that the reason always goes at the end of the switchover. So to get from step 1 to step 2, I put the reason in step 2. To get from the top one to the bottom one, I put the reason in the bottom one. So that reason is still definition of congruent angles. We just don't know what number it is. Okay, so we still need to fill a reason in here. Now I didn't know how long this proof was, so I just put this all the way down at the bottom, and then we're going to fill in the gaps here. So you must convert everything from congruence into equality before you can use substitution or angle addition. So these proofs will all require that you can do that conversion, so that should be an easy step. Now, this is an addition proof, so that's what we're going to do next. We're going to add down. So when we add down, we just add these two left angles together and we write it horizontally. Measure of angle 1 plus the measure of angle 2, and then we add these two together and write them horizontally. Measure of angle 3 plus the measure of angle 4. And it is a simple addition. And so that's the reason, addition property or just addition. This is not angle addition, because angle addition would be part plus part equals whole. Okay, this is definitely not part plus part equals whole. So this is just plain old addition. All right, so here's where we're at. Sometimes in a proof it helps to stop and look at where you're at and where you're trying to get to. So 1 plus 2 equals 3 plus 4, and we're trying to get to ABC equals DEF. But if we look at the diagram, 1 plus 2 is equal to ABC, but it's like what we get if we were to squish it down into a single angle. And 3 plus 4 is the same as DEF if we were to squish it down into a single angle. All right? So we can't go straight from here to here, though, because the reader, or the proof, doesn't know what's going on in the picture unless we state it over here. So in order to contract that into a single angle, we need to tell the proof what's going on in the picture. So that means we need to tell it what angle addition, what parts are going on here. So for instance, the measure of angle ABC is made up of measure of angle 1 plus the measure of angle 2. All right, whole equals part plus part, so that's angle addition. Angle addition postulate, okay? And we also have another whole angle over here, which is DEF. So we're going to break that down as well. Measure of angle DEF equals the measure of angle 3 plus the measure of angle 4. All right, now, the other thing too is that if you've labeled your holes up here in the given and the proof, then those will always become the two holes that you're breaking down. So that is a helpful guide as well. And so we look at the diagram, we know that's a hole and we can figure out its parts, and that's a hole and we can figure out a part. The other thing to think about is that in order to contract this angle into a single angle, we have to have this angle addition step. So the angle addition, I say, is kind of like the machine that allows you to contract it down to a single angle. And basically what we're doing is, since 1 plus 2 is equal to ABC, we're just taking ABC and we're plugging it in place of the 1 plus 2. And that's how we get this. And then we're taking the DEF and we're putting it in place of the 3 plus 4. And that's how we get this. So because we're plugging those things in to get rid of them or to contract them down into smaller angles, kind of like combining like terms, because we're squishing it down into a single thing that it's equal to, then that is substitution. And I'm going to write contract. We want to contract it down into a single angle. Then that would be substitution. But you must have an angle addition step before you do substitution. These have to go hand in hand, these two. They work together. Okay? So that's your basic addition proof. Let's do a subtraction proof then as well. So in this one, we've got angle AOC is congruent to angle BOD. That's your given, and you should always mark that in the diagram. AOC is congruent to BOD, and that is made up of more than one angle, so we write whole. We're trying to prove that angle 1 is congruent to angle 3. We do not label that in the diagram. Only the given goes in the diagram. But we can put that down at the bottom. Angle 1 is congruent to angle 3. Okay. So we're going to do our conversion step to switch these to equality. The measure of angle AOC equals the measure of angle BOD. And we'll do it at the bottom as well. The measure of angle 1 equals the measure of angle 3. So we convert that to equality. Anytime we convert from congruence to equality, that's the only thing that's switching, is definition of congruent angles. So it goes at the end of the switchover. To get from 1 plus 2, I write it in 2. To get from top to bottom, I write it in the bottom. Definition of congruent angles. Okay. Now, we want to go to the diagram and figure out what's going on here. And we know that these two bigger ones are equal. We're trying to prove that 1 and 3 are congruent. But we have a problem. We're at a hole and we want to get to a part, so this is a subtraction proof. but I can't subtract anything from this angle AOC to get down to angle 1 unless I stretch it out into its parts that make up AOC. So in a subtraction proof, you're going to have to expand these into the angles that make up it before you can do your subtraction step. So in order to do that expansion, you're going to have to tell your proof what's going on in the diagram. Tell your proof what makes up angle AOC. That's your whole. So here are your two holes, AOC and BOD. Those are going to go down here. And then you're going to have measure of angle BOD. So you're telling your reader or the proof machine what these two angles will break down into. So the measure of angle AOC is angle 1 plus angle 2. And the measure of angle BOD is angle 2 plus angle 3. And of course, when we do whole equals part plus part, that's going to be angle addition. Postulate, if you want. All right, now that your reader knows what AOC is made up of, then we're going to stretch it out. Sorry, went the wrong direction. We're going to take AOC and stretch it out into its parts. So AOC is 1 plus 2. So instead of writing AOC there, I'm going to write the measure of angle 1 plus the measure of angle 2. So this is step 4. And instead of writing BOD there, I'm going to stretch it out into the measure of angle 2 plus the measure of angle 3. And again, what we're really doing is we're putting 1 plus 2 in place of AOC and 2 plus 3 in place of BOD, so that is substitution. And that this time is an expansion step, so I'm going to write expand. So if you want to contract two angles into one, you have to use substitution. If you want to expand one angle into two, you have to use substitution. Now let's look at line 4 and look at how it's different from this line right here, which is actually going to be line 6. Okay? How do we get from line 4 to line 6? What is different? We got 1 plus 2 and 2 plus 3, and we're getting down to 1 and 3. So the 2's are gone. All right, that's actually what we're going to be subtracting away. But before we can subtract it away, we have to say the measure of angle 2 equals the measure of angle 2. And whenever we say something is equal to itself, that's reflexive property, reflexive property. And once we say that they're equal, basically all we're doing is getting rid of them. We're subtracting. So the reason for step 6 is just subtraction. We're subtracting angle 2 from both sides of the equal sign. And that leaves us with the 1 and 3, and then we convert it back to congruence at the end. Okay? So that's your two basic types of angle addition proofs. One where we add the two parts to get the whole. So we add first and then contract it down using substitution. Or in this case, we have the whole and we want to get to a part, so we're going to have to subtract. So in that case, we stretch out those single angles or expand them into the multiple angles that make up each of them, and then subtract a single piece away.